Okay, I'm back after you've had a little time to do your first couple questions here on the homework, and I'm going to go over them, make sure that we're okay and that we're doing it correctly. First of all, the first problem asked you, first of all, it said in A, which is very simple, it said what's the probability of rolling a number less than 3? So we're talking about one die. We have 1, 2, 3, 4, 5, 6. So a number less than 3 has to be a 1 or a 2. So that's 2 out of 6. Okay. So 2 out of 6 is 1/3, which is 0.333. So it's that simple for A. In B, it wanted us to actually simulate that. And when we simulate that, we have to go to Math, Probability, and we want to get a random integer. Okay. And we want to, the numbers we want to go through is 1 to 6. So 6 is, that's a die, it goes from 1 to 6. And we want to do it 100 times. And we want to hit store, which is right above the on button, and then second, number 1, that stores it in list 1. Okay. Once we hit enter, it will store it in list 1. Next, we want to go to stat, sort, and that sorts you in ascending order is the A, so ascending order, and we want to sort list 1 in ascending order. Now, what I'm going to do is go look at my list 1, and I want to scroll down and see how many 1s and 2s I have. So I'm going to scroll down until I see the last 2. And that's 36 is the last 2 I have. So I had 36 1s and 2s. And so 36 out of 100 is 0.36. That's what I got for my first one. Now, it asks you to simulate this 4 more times. So I'm going to show you how you can simulate this 4 more times. Bring up, if you'll go to Math Probability, 1, 6, 100. Okay. And if you will store it this time in list 2 and hit enter, then just hit second enter, and instead of list 2 change it to second 3 and store it in list 3 and hit enter, and it'll put it in list 3. Then hit second enter to bring up the equation again and go over second 4, this time stored in list 4, and then hit second enter again to bring up the equation, and second 5 and stored in list 5. So what you've done is you've done 100 times, 100 rolls of the dice. You've done it 4 more times. So you have them now in list 2, 3, 4, and 5. And so now you just want to sort those lists. So you have to go to stat, sort, and you want to sort list 2. Second enter, change it and sort list 3. Second enter, sort list 4. Second enter, and sort list 5. Now all 5 of your lists are sorted, and you can go through each one and count how many 1s and 2s you have. So when I did it 5 times, the first time I had 36, second time I had 38, third time I had 33, the fourth time I had 25, and the fifth time I had 33. Then I added up all those numbers together. So 36 plus 38 plus 33 plus 25 plus 33, and I got 165, and I want to divide that by 5 because I did it 5 times, and that's 33 or 0.33. So my average was actually 0.33 for all 5 of them. We know that the real chance of rolling a 1 or a 2 is 0.333, so my average was very close to the approximate probability. Now, when you do it, you may get something a little bit different, but since it's 500 times, it should be very close to that 0.33. Okay. Number 2, 3 children are born, and then number 2, the order does matter. So if you're thinking 3 children are born, and they can be either girl or boy, there's 8 different ways for them to be born. Okay. And the way we know that actually is by the probability formula. The first child has how many options? 2. Second child has how many options? 2. Third child has how many options? 2. 2 times 2 times 2 means there's 8 choices. So it can be girl, 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 boy, girl, boy, girl, girl, boy, 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 girl, boy, girl, boy, or boy, girl, girl. Now, they say in B to assign girls to equal X. So girls stand for X. And we want to know how many times there are 2 girls. So we're going to look over here. Here's one right here. Here's one here. And here's one here. So 3 out of 8 times there are 2 girls, which is 0.375. In C, it asks us to make a table using X. Well, X stands for girls, so there could be 0 girls, 1 girl, 2 girls, or 3 girls. We already know there's 2 girls, 3 out of 8 times, which is 0.375. There's 3 girls only once. There's 0 girls only once. And again, 1 out of 8 is 0.125. And there's 1 girl 1, 2, 3 times, which is 0.375. So we actually made a probability distribution, which is what you saw me do in the example of the discrete random variable. Okay, question number 3 has a lot of parts, but let's just look at them real quick. It says a social class in England. What percent reached class 5? Well, that's just 0.01, which is 1%. B says check that this distribution satisfies the requirements. If you look, I checked that all of them add up to 1, and they do. C, what is the probability that X is less than or equal to 3? So I need to add up 1, which is 0.48, the 2's, which is 0.38, and the 3's, which is 0.08, and that adds up to 0.94. So less than or equal to 3 means 3 or less. D says what's the probability that X is less than 3? So in this one, 3 is not included, so it's just 0.48 and 0.38. And then in E, it says what is the event a son of a lower class father reaches one of the highest 2 classes? Well, the highest 2 classes is 4 and 5. So you can write that as the probability of X is greater than 3, because 4 and 5 is greater than 3. You could also write it as X is greater than or equal to 4. That would be the same thing. But that's just 0.05 plus 0.01. So there's a 0.06 or 6% chance of being in the 2 highest classes. And then in F, it says briefly describe how you would use simulation to answer C. And C was talking about how 0.94 were 3 or less. So we could assign 94 numbers to mean class 3 or less, and then the other 6 numbers could mean class 4 or more, and then we could just start at line 101 and in a table and simulate this and see how many times we could go through a couple trials and see how many times that happened. Okay, so that's just saying set up a simulation. Remember, your percentages help you do that. Number 4, I want you to make 2 probability histograms. Now, those are really easy to make, but you have to be careful and make sure you know what you're doing. So they need to be the same. So notice, I'm going to zoom out just a little bit. In these, since they need to be the same, they need to both go up the same way. So they're going to, the probability is the y-axis. It goes up by 0.1 each time for owned and for rented. And then your x-axis is how many rooms. If you look at owned houses, they center around 5, 6, and 7. If you look at rented houses, they center around 3, 4, and 5. Now what does that tell us? Well, it tells us that owned houses are centered around 5 to 7 rooms and rented houses are around 3 to 5 rooms. So rented homes have less rooms on average, which makes sense because owned houses would tend to have more rooms because you actually own them, so they're probably bigger. Rented houses are probably a little smaller. Okay? Number 5, what's the probability? So it's talking about an owner, if you read the question in number 5. So we're only talking about an owner here. What's the probability that an owner has more than, or has 5 or more rooms? So that would be greater than or equal to 5. So 5 or more. So I'm going to add up 5 rooms plus 6 rooms plus 7 rooms plus 8 rooms plus 9 rooms plus 10 rooms. I get 0.868, so 86.8% chance. Now I'm writing it in words. The probability that the house has more than 5 rooms. if owned. So we're only talking about owners, not renters. So more than 5 rooms does not include 5. So I have 6 rooms plus 7 plus 8 plus 9 plus 10. That's 0.658, which is 65.8%. Then C says, what's the difference between A and B? So notice, in A, it was greater than or equal to. In B, it was greater than. Those are not the same. There's also a difference if we do less than and less than or equal to. That only happens when we're talking about discrete random variables. Okay? So in continuous random variables, there will not be a difference between the less than and the less than or equal to sign, and the greater than and the greater than or equal to sign. That's hard to imagine, but there's not. But in discrete random variables, there is a difference, just like you can see the difference right here, and 1 through 5. So now you're going to go and do 6 through 10. Those are on continuous random variables, like the example I gave you with the women's heights, and that will take you, that's your homework for tonight, and that should be turned in. And you need to get your binder together, because Friday we'll be turning all that stuff in, and I'll give you a quick update Friday morning, or at the beginning of class Friday, about how to do that. But make sure you have everything done for the week and in order in your binder. Alright, have a good day.